square into 1 minus 3t square. Plus sign here because minus plus it has become. So into, if I multiply this, is twice t minus 2t square for tt. T into t square. So this is this into 1 minus t square into dt. Now let me take with caution because answer previously it came out as -1. I mean not right answer. This is 0 to 1. Let me solve them further. Multiplying by 1, it will be 1 minus 2t plus t square as it is. With minus 3t square, it is minus 3t square. Now plus 3 to just 6 into t cube. Okay, then minus 3 into t4. Minus 3t square into t square is minus 3t4. Okay, now this is to be multiplied with minus sign, sorry, plus sign here. Now 2t, this is 2 into t minus 2t cube. Now with the minus sign, it is minus 2t square. Now plus here, plus 2t4. 2t square minus 2t square into t square, that t4 here into dt. Okay, so let me further solve it. So okay, so this is just calculation, nothing so serious one. Let me further solve it. 0 to 1. So here 1 is independent. There is no 1, so this is 1 here. Now minus 2t plus 2t cancelled out. Okay, this is plus 2t 4, no problem. Now t square, let me talk about. T square, this is minus 3t square minus 2t square. So 3 terms are there. This is minus 2t square then, so minus 4t square. Because this is minus 3t square minus 2t square, that is minus 5t square, and plus 1t square, so this is minus 4t square. Now, t square is cancelled out. Now let me talk about t cube. This is 6t cube minus 2t cube. This is minus 4t cube. Minus 4t cube. But then minus plus 2t4 and minus 3t4. It is minus t4 into dt. No problem. I think it is coming out as the same value. Now if I integrate them, let me integrate. So integration of this will be t minus 4t cube upon 3 minus 4t4 upon 4 integration minus t5 upon 5. Same answer is coming. 0 to 1 then. Answer it is coming out as same. This is 1 here. Sorry, this is minus 1 here. Okay. It is minus 1. How did it be minus 1? It is plus 4t4. Where is t cube? This is plus t4, sorry. So this is 6t cube. It is plus 4t4. I'm sorry, t cube. Because 6t cube and minus 2t cube plus 4t cube. This is a plus sign. Alright, so let me now put value 1. It is 1 minus 4 by 3 plus 1 minus 1.5. I think okay, this is 1 only. The answer is coming out as same. So it is not 8a square by 15, but 7a square by 15. Okay, so this is 2 minus 4 by 3 minus 1.5 comes out to be 15 LCM. 15 to the 30 minus sign. It is 3 5 the 15, 5 4 the 20, 5 3 the 15. This is minus 3 here. This is minus 3 here. Okay, so minus 3. That means 20 minus 3 is 23, minus 20 and minus 3, and 23 is 30 minus 23 is 7 only, not 8. Sorry, this is answer is 7a square by 50. So answer is 7a square by 50, not 8a square by 50. Okay, now let me take question number 3. Question number 3, if I take, or I'll check it later, doesn't matter. I'll check it whether answer is 8a square by 15 or 7a square by 50. But it is coming out as the same question. Now question number 3, let me talk about. Okay, so it says prove that the area of the curve x equal to a cos. Let me take to prove area of the curve x equal to, this is a cos theta, a into cos theta plus b sin theta plus c constant. Okay, and y is equal to a dash cos theta plus b dash sin theta plus c dash. Okay, is equal to this, to show that area of these curves is equal to pi into a b dash minus a dash b. Okay, so this area we have to prove. Okay, now let me take this area. Now here we have taken, because this is the curve which is given in sin theta cos theta whole form. So here limits will be, or let me find the solution. Here solution, let me change the marker. Here the curve is lying, okay, is lying in the limits from 0 to 2 pi. Why? Because the whole curve is given x equal to a cos theta, okay, y sin theta, b sin theta plus c, and y equal to this value. The whole area we have to take. Prove that the area of the curve this is equal to this. So limits we have to take 0 to 2 pi. So this whole curve is taken, means 0 to 360 degree. The whole area is taken. So this is limits we have to take. What is the formula? Area of the curve. Area of the curve is given by the formula which we have proved is equal to 1.2, limits here 0 to 2 pi, as we were taking in case of polar coordinates. This is in case of parametric forms. This is x into d by d theta, because here it is theta, minus y into dx d theta into d theta. Same formula, we have to just substitute these values and multiply them, and we will check that whether the answer is coming same or not. Let me check. So here we have to substitute the values 1.20 to 2 pi. Here x value is this. Let me put in bracket a cos theta plus b sin theta plus c. This is value of x. So d by d theta, differentiating this, it will give us a dash as it is. Cos theta differentiated is minus sin theta, minus a dash sin theta, and this is plus b dash cos theta, and c dash is 0, constant, with minus sign in between. We keep y into, now y is a dash cos theta plus b dash sin theta plus c dash into dx upon d theta, means from first one will be a into with minus sign, minus a sin theta plus b cos theta only cos C is 0. Okay, into whole d theta. Let me take. Just we have to multiply them and solve them. Not to commit any error. Let me take very seriously then. So this formula we have applied, and let me solve it. Now multiply them in between. So area is equal to 1.2 limits 0 to 2 pi, no problem. Now if I multiply by into these two terms by a cos theta, first let me take, it will be a into minus a, sorry, so this is minus a dash into cos theta sin theta into cos theta sin minus a dash sin theta, and this is plus sign plus a into b dash into cos square theta, cos into cos. Then by b sin theta we have to multiply this. It will be with minus sign minus a dash b into sin square theta into a square, a dash into b sin square theta, so sin into sin. Then with b sin theta into this, it will be b dash into sin theta into cos theta, sin theta into cos theta, this into this. Now by c, this is minus c a dash into sin theta, first one, then plus c b dash into cos theta. Okay, so we have multiplied this. Now we have with minus sign. So these two are, all these three are to be taken as negative signs. So minus a dash into a, that will minus plus. First step will be plus a dash, because a into a dash cos theta sin theta, cos theta into sin theta, it is positive. And with minus sign, this minus sign, it will be negative sign here, minus a dash b into cos square theta, so cos theta into cos theta. Now by minus b dash sin theta, we have to multiply these two. So it will be then with minus sign a into b dash, this one, what we are doing. Okay, so we are multiplying by b sin theta to minus a, but it will be minus sign and this minus sign positive, a into b dash, this is a positive sign. With this minus sign and this minus sign here, first one with b sin theta, it is a b dash sin square theta. Okay, then with negative sign this and this is negative, minus sign b dash into sin theta cos theta into sin theta cos theta with negative sign here. Okay, then by minus c dash we have to multiply these two. That will be minus sign plus sign, first one, a into c dash, it is sin theta only. Then with this minus sign, it will be negative c dash or b c dash into cos theta into d theta, last value. So this is from this point. What are the similar terms, or like terms? Let me add them and subtract them, or if there is any possibility of plus sign or something. So we will to check like terms from a dash, etc. Okay, constant, I mean a, b and a dash, b dash, whatever. First is a dash, a dash, this is minus a dash. Let me take, this is plus a dash cos theta sin theta, this is cancelled out. Okay, this is cancelled out completely, no problem. Then a b dash, let me check whether a b dash is coming somewhere. A b dash, this is sin square theta. So what we have to do, let me write here 1.2 limits 0 to 2 pi. So this second step, AB dash, we are taking common. Into this is cos square theta plus is sin square theta. These two are similar terms. AB dash and AB dash is sin theta, we are taking. Okay. Then comes out to be minus A dash B. This is minus A dash B. Similar terms, this is minus A dash B into sin square theta minus sin square plus cos square theta. So this A dash B and this is A dash B. Both are with negative signs, so minus sign we are taking common. Inside the bracket it will be plus sign, so it is sin square theta plus cos square theta. These two have been taken. Okay, so this is also over. Now BB dash. This is BB dash, this is BB dash. This is plus sign. This negative sign, so these two are cancelled out. BB dash. This must be plus sign here. BB dash was plus sign. Okay, let me take plus sign, no problem. So it is there. Then the other thing, now we have to come out to be CA dash. This is CA dash here, this is C dash. Okay, not coming, sin theta is coming. It is, these two are not, but sin theta is common only, so constant are there. So plus sin theta, if I take common, it will be this positive AC dash minus A dash C. So these two CA dash and AC dash we have taken common, no problem. Then CB dash, and this is BC dash, the negative is positive. Again we have to take plus, let me take cos theta common. This is CB dash, this is minus BC dash. This is covered. Okay, so all terms are now covered. This has been covered. We have the four terms here and into whole d theta. Okay, now let me integrate this. So this comes out to be this whole value. So what is that? Let me check it. Now this is 1. So let me further write it down. 0 to 2 pi. First is A B dash and minus A dash B, because this is also 1 into d theta. Let me separate them. It's A B dash because this is 1 here, as sin square theta plus cos square theta is equal to 1. From trigonometry, this is 1, this is 1. So this is A B dash minus A dash B. Alright, into d theta we have separated them. Now these two are okay, constant terms and multiplied by cos theta sin theta. Let me integrate them separately. So this is separated. Plus sign, this is 1.2 here. So sin theta is integrated as minus cos theta. So it is minus cos theta, let me take, into AC dash minus A dash C. I have integrated this. This is a separate function. I'm just integrating them, these two, and then putting the limits. The limit we will put before. Let me take these two terms together after integration. Cos theta integrated is sin theta. It is sin theta here. 1.2 is okay. Sin theta into CB dash minus BC dash, limits 0 to 2 pi. Okay. So what it comes out to be at 2 pi, okay, and 0. So sin theta is coming the similar value, but this sin theta will be 0, cos theta will come out to be. Let me check what it comes out to be. So first term is 1.2, this one. Theta is LCM, so 2 pi into theta. So this is 2 pi into these values will come out as AB dash minus A dash B. Why 2 pi? Because this integration is theta into this constant, and put the limit 0 to 2 pi, so 2 pi only will be kept, will be substituted theta. Theta will be substituted with 2 pi only, the upper limit. At 0 it is 0, so only this value. Now plus, second step, this one. Now minus cos theta, if I substitute 2 pi, it is cos 2 pi is 1 positive, it is minus 1 only. 1.2, it is minus 1. Then when we put the lower limit 0, that will be plus 1. Why? Because minus sign is become positive because we put the minus sign in between when we put the lower limit. Before putting the lower limit, we put the negative sign, but negative is already there, so it will be positive. Plus sign, cos 0 is 1, this is 1, and multiplication is with A C dash minus A dash C. This is 0 here, so it is 0. Cos is 0, and sin is already 0 because sin 2 pi is 0, sin 0 is 0, that is also 0. Okay, so this value only comes out to be, because these two values are 0. This is minus 1 plus 1, 0. 0 into something 0. So these two are, these two to cancel out. So this is pi into AB dash minus A dash B. Is it the same answer? Let me check. Question number 3. Okay, pi AB dash, yeah, minus A dash B. Exactly right. This is the right answer. Question number 3 we have done. Okay, so question 3 has the right answer. Good answer. Okay, so question number 3 is completed because it is the same answer. But in question number 2, I'm just surprised that why it is coming 8 square upon 15. Our answer was coming 7a square upon 15. That I'll check later. I'll tell you that when I take after the last time whether this answer is right or wrong. That I'll check. Okay. After that I'll tell you when I take the ending part of this. Okay. Let me take now question number 4. Question number 4, let me check. What does question number 4 say? Question number 4, or fourth question is of what kind? It says if P be any point on the ellipse, okay, which is x square upon a square plus y square upon b square equal to 1, and S be the sectorial area bounded by the curve, okay, the x-axis and the line joining the origin to P, okay, show that x equal to, okay, this is similar type of hyperbolic function. Let me solve it. So it is question number 4. Now it says ellipse is there. It is the ellipse here. And take this is the ellipse, sorry, not coming proper one. It comes out to be like this. Okay, this is the ellipse here. This is origin O. If I take P point here, okay, so this is the P point here, and this is A point to vertex of this x-axis, x dash axis. This is y dash. This is B point. This is B dash point. This is A dash point. Okay. So if I take, so we have to find out area OAP is sectorial area. Yeah. So at point this, if I take r and theta is coordinates, what are the points here given? Or we can take a cos theta, okay, x equal to a cos theta and y equal to a sin theta be the parametric form of this equation, and then area we have to find out. Okay, let me take theta is the angle here. Here theta equal to 0 at a point. At P theta is theta. Let me take theta equal to theta. At this point this is theta here, and it is Q, no problem. We have to find out only AOP, the area, the sectorial area. Let sectorial area OAP or AOP. This is OAP. What is given to us? Nothing. P be any point on the ellipse. Then S is the sectoral area bounded by the curve. Okay, by the curve, the x-axis, by the curve and the line OP. Curve, the x-axis and the line joining the origin to P. Origin to P. Okay, so OP line. So this is AOP area. Okay, so the select sectoral area AOP. Sorry, AOP here. AOP is equal to S. So S is given by the formula we know. By the formula. Okay, by the formula we know this is 1.2. Limits here 0 to theta, let me take 0 to theta. Okay, here x d by d theta minus y into dx d theta into d theta. For that we have to consider that x equal to a cos theta and y equal to b sin theta. It is b sin theta. B sin theta be the parametric equations of the ellipse. Parametric equations of the ellipse given. Of the ellipse. Okay. We have to find out dx dy. What is, therefore here x equal to, we have taken a cos theta and y equal to b sin theta. Okay, so therefore dx d theta, okay, this implies that, or therefore this implies that dx d theta from first one is equal to minus a sin theta. Try to understand. Cos theta differentiated as minus sin theta, and d by d theta is equal to b cos theta. Simple. So these values are to be substituted in this formula, and x and y also. Let's multiply them. Therefore, this is area 1.2. This is S equal to, we are finding out. So S equal to 1.2, 0 to theta. Limits, let me take. X is a cos theta. This is a cos theta. Okay, now d by d theta. This is d by d theta, which is equal to b cos theta. It will be b into cos theta. The minus sign in between. Y is b sin theta. B sin theta, and dx d theta is minus a sin theta. Minus a sin theta into d theta. Okay, with respect to d theta. So what do we see here? This is 1.2, 0 to theta. A into B common, AB. So AB is common. What is left over? This is cos square theta. This is minus plus sine square theta. Simple into d theta. This is 1. This is nothing but 1.2 AB into 0 to theta limits. It is 1 into d theta. Integration will be 1.2 AB into theta. Now limits 0 to theta. It is nothing but 1.2 AB into theta. Okay, so this is equal to S. Therefore, theta is equal to. So we have obtained here theta is equal to 2 into S upon A into B upon AB. With AB theta, we have obtained that 1.2 AB into theta is equal to S, sectoral area. Therefore, theta is equal to, this implies that theta is equal to 2 into S cross multiplication divided by AB. So in place of theta, if I substitute this value 2S upon AB, so we will obtain x equal to A into cos of twice A upon AB, twice S upon AB, and y equal to B into sine of twice S upon AB. Hence it is proved. So the value obtained, therefore x equal to A into cos of theta. Theta is twice S upon AB, and y is equal to b into sine of twice s upon ab. This is obtained. Hence the answer. Question number 4 is this: y equal to b sine twice s upon ab. We have to prove so that x equal to this and y equal to this. Hence it is proved. This we have proved here. Okay, so this is question number 4. Now let me take question number 5. What does question number 5 say? Let me check it. Question number 5. I'll take this only. After that I'll take break for 5 minutes. And then we'll talk about other things. Question number 5 says, prove that the area bounded by the hyperbola, this, the x-axis and the ordinate from this point P, A cos the hyperbola theta, B sin hyperbola theta is 1.4 AB into sin hyperbola twice theta minus 2 theta. Okay. Now let me take question number 5. It says, so the area bounded by the hyperbola. What is the hyperbola here? We always draw like this hyperbola. So this is the hyperbola. Second hyperbola is this. Second part of this hyperbola. Or we can say left part of this right part. This is x-axis. And this is the origin O. A, the x-axis. Okay, so area bit found between the x-axis, the ordinate, the point here. Okay, so P point we have to take. So P point is here. So it is P point is A cos hyperbolic theta cos hyperbolic theta and B sin hyperbolic theta. So A point is here. Limits are first is r and theta. Okay, so limits for prove that the area bounded by the hyperbola, we have theta equal to, we have to take this A cos hyperbolic theta, which is the limit here, upper limit. X limit, because we are taking between the x-axis. So the limit for x coordinate is this. This is just x coordinate here. So here x equal to 0. Sorry, limit we have to take here on this point. If I take x coordinate here, it is 0 here. Or we can take, where is the x coordinate or y coordinate, what we have to think about. Okay, so there's the area bounded by the hyperbola. There is the x-axis and the ordinate from. So x coordinate we have to find out from this.